Welcome to this advanced series on ADF. My name is Lynn Munsinger and I'm a product manager on the JDeveloper and ADF team. In this ADF Insider session, we'll focus on project considerations for team development. This session will cover three main areas. First, setting up the JDeveloper environment for working in teams. Secondly, how to organize development teams. And third, how to develop an application with reusability in mind. Let's start with the considerations for working in teams. The first consideration for developing in teams is the use of version control. JDeveloper supports many popular source control systems, including Subversion, CVS, ClearCase, and others. Support for Subversion is built into JDeveloper, without the need to download a separate extension. Version control systems allow you to integrate code changes, maintain code history, compare and revert to previous versions, and branch code. Typical activities include an initial import of the source code into a repository, check-ins from a developer's working copy to a source repository, and updating a working copy with changes from a repository. The root of the repository is typically the application, although for more segmented development teams, the root might be a JDeveloper project. The pending changes window shown in the bottom of this slide shows three tabs: outgoing, candidates, and incoming. These tabs are useful for determining which files I have changed, which files I've created and are therefore candidates for addition to the source repository, and which files are incoming changes that have been checked in for my team members. I can specify the amount of time between checks for incoming changes, and I can also add additional properties like SVN externals via the Tools Preferences menu in JDeveloper. One of the most helpful aspects of the code editor is the History tab. This dual view allows you to see who made which changes to a source file. This tab is available whether or not you're using a source control system in order to view the differences between either save points or save points and checked-in versions. When two developers check in the same file with different changes, a conflict is generated in the source control system. JDeveloper helps you resolve this by providing a three-column view containing each checked-in version, as well as a merged version in the center to resolve the file conflicts. Branching, tagging, switching, and merging files are all available in JDeveloper's version control support. Let's take a look at a typical branching example. First, a development team checks out from the source repository, typically called the trunk. Changes are made to the source code in a developer's working copy and then checked back into the trunk. When a branch is required for a new feature set, for example, developers can perform a switch operation to change their working copy to point to the branch. Changes are then committed back to the branch. When the branch needs to be reintegrated into the trunk, such as after a release, developers can switch their working copy to point to the trunk. Changes from the branch can then be merged into the developer's working copy. Any conflicts resulting from the merge are resolved. And finally, the results code is checked back into the trunk. Here are some good tips for working with version control. First, it's advisable to use the JDeveloper extensions for version control rather than mixing and matching other version control clients, because JDeveloper tracks accompanying files that might not be obvious need checking in. Secondly, developers should commit often after working with a logical chunk of files so that all related artifacts are checked in simultaneously. Third, never blindly merge XML files. Instead, use the Resolve Conflicts dialog to merge XML source changes. Finally, there are several registry type files that are modified frequently as other files are added and modified. For example, the data binding CPX file will be updated each time bindings are added to a new JSPX file. Teams should develop special policies for these aggregate files so that developers know when to check them in. Oracle's strategy for application lifecycle management is not to provide yet another ALM solution, but instead to bring the best-of-breed solutions from the industry together into one centralized service. Our solution uses best-of-breed solutions and plugs them into JDeveloper via adapters. These solutions for collaboration, reporting, and process automation are brought together and can be linked to one another so that relationships between the artifacts are available to help teams work collaboratively. This service integration is called Oracle Team Productivity Center, or TPC. In TPC, third-party repositories are integrated to help teams work together effectively. Let's take a look at a developer's day-to-day. There's code, of course, but there's also project plans, specifications, defect reports, etc. Team Productivity Center pulls all these bits of information into the developer's IDE, into JDeveloper. For example, say I'm a development manager with several developers reporting to me. I can look at all the bugs scheduled for today, check the project plan, and even start a chat session with the developer to see how the work is progressing on a particular bug, or tag it for discussion at an upcoming status meeting, all from within JDeveloper. The collaboration client is also available for instant messaging right from the IDE. Additionally, a connector development kit is provided so that organizations with their own homegrown bug repositories can integrate with TPC. The screenshot here shows a team listing from the server on the left and a resource, in this case a bug report on the right, all within the JDeveloper IDE. Developers can relate services to one another and tag them so that Rally tasks and defects can be linked to code, Jira issues can be updated, and Bugzilla bugs can be tracked and tagged by team members. There are three main parts to Team Productivity Center. The first is a series of connectors to integrate repositories into JDeveloper. The second is the server portion, which defines who's in what team and which team uses which resource. The third component is an integrated chat feature that can be connected to any XMPP chat server. Now let's take a look at organizing teams for larger projects. There are several considerations for organizing a team. First, consider your team's strengths. In a large project, there are enough tasks for developers to specialize in different areas. Small teams need stronger developers to share the tasks, but no matter the team size, communication is key. Developer roles are typically divided into service specialists and UI specialists for web application development, and orchestration specialists create automated business processes. Development teams typically separate DBA duties as well. For larger projects, framework extensions and project infrastructure responsibilities can be divvied up so that one team's infrastructure code, such as utility classes, can be an input for other teams working on other projects. For larger projects, the management of the release and coordination among different product lines might be handled by a designated individual or team. In a perfect world with unlimited resources, each product line has their own subject matter expert that works on the particularly difficult issues for each product's orchestration, service, or UI specialist team. A SWAT team containing UI, services, and/or SOA experts can oversee issues from across product lines. Additionally, separate teams develop infrastructure code, such as utilities, skins, or UI components. Designers develop patterns and graphics. The output of these teams might be a set of coding standards, a template, or a jar file containing framework extension code. When developing multiple product lines, a team, or a team of one, is needed to coordinate the release of the product. This team is responsible for determining and coordinating dependencies between products. For example, when the output of the framework team is a jar file, when will product lines uptake changes to this file? How will that file be coordinated with testing plans? What version of each product will work with which version of other products? All of these considerations are important to communicate among development teams. To automate the build and deploy process, two commands are available: OJ deploy and OJ server. Development teams can use these commands in conjunction with Ant tasks to create automated build and deploy scripts. OJDeploy will act on deployment profiles for IR, WAR, or JAR files in a particular project or application. OJServer is a background process that runs any number of deployment targets as they are submitted. Obviously, this is not a full continuous integration system. For that, you might want to use a product like Hudson, but this does get you started down the road to automating the build and deploy process. Now that we have our team and source code repository set up, let's talk about other considerations for developing reusable applications. Duplicating code or content is one of the worst practices in application development, but it is one of the easiest mistakes to make. Maintaining the application becomes much more difficult, which means that in the long term, you can't adapt to new user requirements or fix problems quickly. Ideally, an application shouldn't contain multiple versions of the same code, and web content shouldn't be copied and pasted. So to increase developer productivity, consistency, and maintainability, reuse code across modules and projects, create reusable UI components, and use code and web UI templates from the outset of application development. There are many opportunities for reusability in ADF applications. First, the resource catalog in JDeveloper lists the available resources for use in developing an application. This may be a file in a file system, a deployed jar file, etc. ADF libraries are a unique way to package reusable ADF components, discussed further in some later slides. Page templates and declarative components are used to build a consistent user interface among pages in an application. Task flows allow for reuse of pages, method calls, and other activities that make up a task. Portlets and skinning govern the display of the user interface so that it contains a consistent look and feel. But don't forget the obvious thing. The first rule of reusability is that Java is an object-oriented language, and so you should take advantage of features like inheritance and polymorphism. ADF honors these capabilities, of course, and so you should refactor code that is common across multiple entity objects or view objects into framework superclasses that can be inherited by all ADF components. Additionally, polymorphic entities can be used to define different types of the same entity object, which is especially useful for creating unique attributes or validation rules. One of the first best practices you should implement in an ADF Business Components application is the use of base classes. Create base classes that extend application module impl, entity impl, view object impl, and view row impl from the oracle.jbo.server package. You can then specify these classes as the default base types in project properties under the Business Components Base Classes node. Even if your base classes only call the super method for now, it will be much easier to implement changes across all objects in the future. For example, if you want to mark rows as deleted or move them to a logging table rather than actually deleting them when any row is marked for deletion, you could override the remove method of the entity impl base class, and this would implement the behavior across all entity objects that extended the base class. The resource palette is a window into the many disparate resources your application may need to consume. It enables you to define connections to resource providers and to drag and drop those resources into your application as needed. The resource palette provides a search tool to search all the defined repositories in a single action. Connections can be created for resource repositories such as application servers, databases, file systems, UDDI registries, Ambient servers, WebDAV servers, etc. From the resource palette, you can create new catalogs or connections, or import existing ones from an archive. You can also search for a resource. To add resources to a catalog, create a connection to those resources in the Connections panel of the resource palette, then right-click and choose Add to Catalog to add the library, database connection, or WebDAV location, for example. In the course of application development, components are often used more than once. Whether the reuse happens within the same application or across different applications, it's advantageous to package these reusable components into a library that can be shared between different developers, across different teams, and even across departments within an organization. An ADF library provides a practical way to create, deploy, and reuse components. For example, you can create an application module for a data model and package it up to be used as the model project in several different applications. Or if your application consumes components, you may be able to load a page template from an ADF library jar to create pages with a common look and feel. The ADF library is just a standard jar archive file that contains extra metadata about its contents. Let's take a closer look at the types of components you can include in an ADF library. You can include various types of components in an ADF library jar file, such as a set of business components, a reusable task flow, a page template or task flow template, or even a reusable UI component called a declarative component. The first tenet when building ADF libraries is to avoid naming conflicts and make it easy for consumers of the ADF library to identify the component they need by using strong naming conventions. Use unique and relevant names for the jar file itself, as well as for the package that the application module, task flow, or any other component of the jar file resides in. You and your team should decide on the type of repository needed to store the library jars, where to store them, and how to access them. You should also consider how to organize and group the library jars in a structure that fits your organizational needs. The file might be checked into source control or available on a networked file server or both. You should also consider when the code is shared. Teams may need to update changes to the file regularly or on a specific schedule. An ADF library jar file corresponds to a specific project. So if you want to reuse components from multiple projects, you'll need to create an ADF library jar for each project. To package and deploy a project to an ADF library, first go to Project Properties in the project that contains the component you want to reuse, and create a new deployment profile of type ADF library jar file, as shown in steps 1 and 2. As shown in step 3, you can make any necessary changes to the library, such as adding dependencies. Finally, deploy the file by right-clicking the project and choosing Deploy to ADF Library Jar, as shown in step 4. Once a jar file is deployed, you can add it to a consuming project by creating a new connection to it from the resource palette, as shown in steps 1, 2, and 3. The jar file will then appear in the resource palette, as shown in step 4, and you can right-click to add the library to the active project that you have open in the IDE. You'll then be able to use the contents of the library by creating new view objects based on a library's entity objects, or by creating pages based on the library's data controls, or by creating pages based on the library's template, for example. When deploying a library for reuse, there may be some business components that are not intended for reuse, but must be included in the library because other components depend upon them. For example, if you only want consuming projects to use view objects in the library, but not provide the ability to view or use the entity objects, then you could mark the entity objects as private before deploying the library. When an object is marked as private, it is not visible in the resource catalog or in the application navigator of the consuming project. Regardless of whether ADF libraries are used, modularity of business components should be considered when developing applications. For example, many projects start out with one monolithic application module, but ideally, application modules should relate to a single end-user use case. For example, a back-office user might need access to one set of view object instances for administration purposes, and a customer user would need to access another set of view object instances. In this case, even if the underlying entity objects were related to the same database schema, two application modules should be created to separate these use cases and provide for reusability in other applications. Thus, view object instances can be shared across application modules, and application modules themselves should be seen as containing composite business logic from a set of entities. Additionally, view objects can be reused by creating unrestricted base queries and then changing the view object query for different purposes by appending view criteria. Finally, bounded task flows ensure that application modules are nested at runtime if necessary. So the careful planning of task flows as reusable components themselves will help to ensure the reusability of application modules. In summary, set yourself up for success when building applications. Create a team that communicates effectively, shares resources, and implements a well-thought-out project infrastructure. Develop a culture of reusability so that your development team constantly looks for places to encourage and support reusability. The payoff for this might not be prevalent in Release 1.0 of your application, but certainly by Release 2.0, your team will have reaped the benefits of an agile, easily maintained application, and your users will appreciate the application's consistency and your team's ability to quickly adapt the application to changing business needs. For more information, access JDeveloper's homepage on OTN at oracle.com/technology/JDev. Thanks very much for your time.